Math Stars, welcome to your first lesson in quarantine. I'm excited to be teaching. I hope you're excited to be learning. Go ahead and take some excellent notes on this in your journal. And I'm going to have you upload a picture of your notes into Canvas so I can see that you took amazing notes. Don't worry, you're not going to have to write a lot down. We're just doing 3 examples today. This is our lesson for the week. Usually you're used to having a daily lesson, but this lesson is for the whole week. We are simplifying, multiplying, and dividing rational expressions. What's a rational expression? It's an algebraic expression that's written in the form of a fraction. So first example says to simplify. What do we do when we simplify? Well, the first thing we're going to do is we're going to factor the numerator and denominator. So I'm going to have you go ahead and pause the video, factor the numerator and denominator, because I want you to get the practice factoring. So I know you want to be lazy and let the video keep rolling. Pause it. Do the right thing. Pause it and factor. Okay, hopefully you listen to me and pause it like I told you to. When we factor the numerator, you get x plus 7, x plus 4. In the denominator, we factor out a greatest common factor of 2x. That leaves us with x plus 4. So our first step in this problem is to factor the numerator and denominator. Okay, second step is to cancel any like factors. So cancel any like factors. So we're canceling any factors that are in common in the numerator and denominator. So the x plus 4s are a like factor. Those can cancel. Now we're left with x plus 7 over 2x. We cannot cancel any more factors. Some people want to cancel out this x and this x, but this x on top is not a factor. That x is not multiplied times anything in the numerator. So because that is not a factor, it can't be canceled out. If the 7 and the x were multiplied in the numerator, oh yeah, then for sure we could cancel those x's because in the top there'd be a factor of 7 and a factor of x. But as this problem is currently written, the x is not a factor. It cannot be canceled out. Okay, the first 2 problems on your homework assignment are going to ask you to give any values of x for which the expression is undefined. Basically, a fraction is undefined if the numerator equals 0. So for example, if I had 3 divided by 0, this would be undefined. So let's take a look at this step here. Let's look at the denominator. I have a factor of 2x, and I have a factor of x plus 4. If either factor in the denominator equaled 0, this expression would be undefined. So let's solve this. So if I solve this for x by dividing by 2, I get x equals 0. Solving here for x, I get x equals negative 4. So this problem is undefined, or this expression is undefined for x equals 0 and x equals negative 4. Now how did I get that? Well, I went up to the step where I had an expression factored before I canceled it, and I determined the values of x that would make the denominator 0. So this problem has 2 answers, as a simplified expression, and then I'm giving the values of x for which the expression is undefined. Okay, example 2. This one says multiply. Basically, we are going to factor everything. Factor all polynomials. And then we are going to cancel any like factors. Okay, so pause your video and factor all 4 polynomials you see. Okay, so when you get this expression factored, we factor out a greatest common factor of x. This denominator, hopefully you factored it as a product sum. Okay, the numerator of the second expression, we're going to first factor the negative out. So I'm going to do this one off to the side and factor the negative first. And then I'm going to factor it as a difference of 2 squares. So I'm just doing this off to the side since it was kind of like 2-step factoring. That way, once I have my final factored form, how do you like that alliteration? Once I have the final factored form, I can replace that back in the rational expression. Factoring this denominator using product sum method, we get x plus 2x plus 4. Okay, now this is really fun and satisfying. We're going to cancel all the like factors. Basically, any factor on top can cancel the same factor in the denominator. Okay, let me switch colors here. Got to show Sparty some love. Go over to green. Okay, so this factor of x plus 3 can cancel. Likewise, we can cancel a factor of x minus 2 and x minus 2. Any like factor in the numerator and denominator can cancel, whether they're on the same fraction or on different ones. And finally, the x plus 2's can cancel. I think we've done all the canceling we can. Let's go back and revisit what we have. So what we're going to do to finish up is we're going to rewrite remaining factors as one rational expression. All right, be rational, dude. Awesome. So we're going to look in the numerator. We have a factor of a negative 1 and a factor of x. Factor of x plus 4 remaining in the denominator. Basically, we didn't actually multiply anything together. The multiplying just comes when you write all of the remaining factors as that single rational expression. Okay, $1 million question, math stars. Can I cancel out these x's? No, those are not like factors. Those are the same variable, but they're not like factors. So those cannot cancel. So this is our final answer. All right, heading over to example 3. Kind of sad that we're 2/3 done with this already. Man, maybe I could make up 4 more examples. That would be awesome. Okay, so on this one, we're dividing rational expressions. So to divide rational expressions, we're going to act like we're dividing fractions. So when you divide fractions, you do keep it, change it, flip it. So we're going to rewrite using keep, change, flip. So possibly in middle school, you learn to divide fractions. So when you divide fractions, you keep the first fraction the same. You keep it. You change the division to multiplication. And you flip the bottom one, or flip the second one. So we're flipping the second expression over. Keep, change, flip. The first one stays the same. Change the division sign to multiplication and flip the last one over. What comes next? Hey, now we're going to finish it up like that last problem. We are just going to factor all polynomials. Whoop, whoop. And then we are going to cancel. Okay, we saved the best for last. Everybody's favorite, factoring by guess and check. So let's see, we're going to put a 3x and an x because those are the only integer factors that multiply to that 3x squared, the only positive integer factors. Okay, so now to get 8 back in the back, we have to multiply either 1 times 8 or 4 times 2, or we can flip the order. Pause the video and give it a try. Okay, I think from what I remember, I worked this problem earlier, we want the 2 here and the 4 here. The reason being is if we have the 2 and the 4 in those places and I do the outer product, I get a product of 6x. When I find the inner product, I get a product of 4x. Those can add to give me negative 10 if I make both signs negative. If you had the 2 and the 4 reversed and you think you got it correct, that's close, but if you pay attention to the signs, you'll see that they don't quite work out. So it has to be factored in this way in order for all your signs to work out. In the denominator, I want to flip that around and make the x positive. And I'm allowed to do that if I factor a negative. Factoring a negative out changes the sign on the negative, changes the sign on the x to positive. Factoring out the negative changes the sign on the 2 to a negative. And on the last expression, we're factoring out a greatest common factor of x and a greatest common factor of 2x. All right, math stars, time to do some canceling. Okay, so we're canceling out any like terms in the numerator and like terms in the denominator. So the 3x minus 4's cancel. The x minus 2's cancel. What else cancels? The x's. These x's are allowed to cancel out because they're multiplied. Basically, when anything is multiplied in the problem, you're allowed to cancel it out. If we backtrack a step, these x squareds can't cancel because they are not multiplied to another factor. They're added or subtracted to something. But once you get the problem factored, you basically change into a big multiplication problem and then you can start canceling stuff out. Okay, so in the numerator, we only have left the x minus 1. In the denominator, we have a negative 2, and then that's it. So this is our final answer. All right, and our last step was to cancel any like factors. Okay, math stars, go ahead and work on the homework that I posted on Canvas. Upload a picture of that to me when you finish, please. And then you'll find a performance task that I am going to unlock for you on Wednesday morning for you to finish on Wednesday or Thursday. Thanks for learning with me.